Okay. Whew. Application final review number 5. College production of a Music Man. So you're told 510 tickets all sold. Again, I'm going to paraphrase a lot of this because I assume you've read this and played with it and fought with it. If you haven't played with these and done them and fought with them some, stop. Don't watch this. Go play with them, fight with them on your own, and then look through all this. It'll do you a lot more good. So 510 total tickets were sold. The tickets had $8, $10, and $12 as their pricing. And income from the tickets was $6,200. And you're told the combined of $8 tickets and $10 tickets was 5 times the number of $12 tickets. Okay, again, I paraphrased that just so I can refer to it. Now, we're asked how many of each were sold. So we know our question is going to have to be answered by something to the effect of there were blank $8 tickets, blank $10 tickets, and blank $12 tickets sold. So we're going to have to find three different things. So we're going to have 3 different variables. So let's pick those variables. We want to let x equal, now be careful here, x isn't $8, it's not $8 tickets. You want to be as specific as possible here. That x is the number of $8 tickets. Y is the number of $10 tickets. And I'm going to use Z is the number of $12 tickets. You want to be as specific as you can about what your variables are. Even this, I was doing this on purpose, even this is kind of sloppy. We're not going to say there were blank $8. We're going to say there are blank $8 tickets. There are blank $10 tickets. I know I said that when I was saying it, but you'd be surprised the power of writing it when you're writing out what you're doing. So make sure your variables are very, very distinct and very, very well defined. Now, in terms of these numbers of tickets, we're told essentially 3 separate things. We're given some information about how many tickets were sold. We're given some information about how much income was generated. And we're given a relationship between how many of each. These are 3 separate equations. The statement 510 tickets are sold, that's an equation. That's going to be our first equation. The income was 6,200. That's going to be our second equation. This relationship, I'm just going to say the relationship about how many tickets of the 10 and the 8 and the 12s, how many of those were sold. Each of those sentences is going to become one of our equations in terms of x, y, and z. Now, since our variables are very clearly numbers of tickets, we know that the number of $8 and the number of $12 and the number of $10 tickets altogether has to equal 510 tickets, so that's a fairly nice equation. The number of $8 tickets plus the number of $10 tickets plus the number of $12 tickets has to all come together to equal 510. Now, income. We know the income is going to be the income from the $8 tickets plus the income from $10 tickets plus the income from $12 tickets has to equal 6,250. So how do we figure out how much income we get from $8 tickets? Well, we take 8 times the number of tickets gives us the income from $8 tickets. 10 times the number of $10 tickets is going to give us the income from $10 tickets. Plus 12 times the number of $12 tickets is going to give us the amount of income from $12 tickets. Altogether, that has to equal $6,200. So that's 2 equations. Oh, but we have 3 unknowns. We need 3 equations. So luckily, we will given one more relationship. This is often the sticky relationship in this problem, but just make sure you read the sentence carefully. It says the number of $8 tickets, well, we have a symbol for that, X, plus the number of $10 tickets, we have a symbol for that, Y, was. That word was is a very big word. That's your verb. Was, is the same as, was equal to. That's where the equal sign is in your equation. The number of $8 tickets plus the number of $10 tickets was 5 times the number of $12 tickets, Z. People often want to multiply this by the 5 because you're told that this is 5 times as large. So you want to multiply this times 5. But to make them equal, if this is so big, if the X plus the Y, if this number of tickets was so big, to make them equal, you better multiply the smaller number by the 5. So make sure that 5 is being multiplied by the right piece. But again, look for that verb, look for the is, the was, the were, to try to make that equation. Now, just to make everything line up, we might want to put that as X plus Y minus 5Z is equal to 0. But that's going to build us a system. And be careful, this problem says set up but do not solve the system of equations that will provide the answer requested. That is the system. You are done. I always feel bad when a student will take 10, 15, even 20 minutes to solve the system when you're not asked to. If you're told to set it up, set it up. If you're told to solve it, solve it. Okay, so that's 5. Okay, 6. A theater presenting a program on drug abuse for parents and children. Admission is $2 for parents, so $2 for parents and $1 for children. You're told that you have a maximum of, where is it? Lost it. 150 people, so 150 chairs or 150 seats, whatever. And then the complicated one, for each 2 parents, there must be at least 1 child. So for every 2 parents, there is at least 1 child. Now that's always the complicated relationship. So we'll talk about that more in a second. So we want to set up an objective function and a system of constraints that would find the maximum money that could be raised in terms of the number of children and parents in attendance. So this is essentially talking about a linear programming question. So first, we need some variables. Because we're talking about linear programming, it's often nice to use x and y. I usually like to use things like p and c, but linear programming, x and y can help. So I'm going to say let's go with x equal the number of parents, and let y equal the number of children. I can't stress enough how helpful it is when you're doing these problems to make sure you write out what your x's and what your y's stand for. It'll make your work more clear, so if something went wrong, I can be much more helpful in trying to figure out what you did so I can give you some points for it. It'll help you stay more organized because you will be definite about what things stand for. Whether it's children or parents or money won't kind of change partway through the problem. So being real specific and writing this out for yourself can be extremely helpful, and it only takes a moment or two. So try to be in that habit. So the first thing we need here is an objective function. So our objective function, we're told here, is to get the maximum money coming in. So our money comes from $2 for every parent. So 2 times the number of parents is going to be the money coming in from parents, plus $1 for every child, y. That 1 isn't necessary, I'm just trying to be clear. So $1 for every child, y being the number of children, is going to equal our revenue. And that's what we're trying to max, is revenue. So this is our objective function. Now, if we wanted to make as much revenue as possible, heck, have 1,000 parents come in and 10,000 kids come in, and we're going to make a whole bunch of money. But we have some constraints. The maximum number of people that we can have is 150 people. So our number of parents plus our number of children must be less than or equal to 150. Now still, we get more money from parents, so why not just have all 150 be parents? Well, for every 2 parents, we have to have at least 1 child. And now, as I said, this is the more complicated relationship. If you're unsure about what to do with that relationship, make yourself a chart of parents and children. What numbers of parents and children would be okay here? Certainly, if we had 2 parents, we'd have to have 1 child, right? If we had 4 parents, every 2 of them has to bring a child. So at 4 parents, we'd have to have at least 2 children. At 6 parents, we'd have to have at least 3 children. So notice the number of parents is twice the number of children. But we can have more children if we want. So there's at least 1 child. So we could also have 6 parents and 4 children, or 5 children, or heck, 15 children. You can have all the children you want. But the number of parents, I'm going to use P for a second here, the number of parents has to be at least 2 times the number of children. 2 times the number of children. If you're unsure about the direction of your inequality, well, try to check your things here, your values here. 4, well, 4 is equal to 2 times 2, but this 6 and 15 is a nice example. We can have 6 parents and 3 children, 4, 5, 6, all the way up to 15 children. And does that make this statement true? Is 6 less than or equal to 2 times 15? Well, sure it is. So this relationship, the number of parents, which is formally x, has to be less than or equal to 2 times the number of children, y. So in this problem, this is certainly the complicated relationship. So x has to be, I'm actually going to say x minus 2y. has to be less than or equal to 0. I'm just going to subtract that 2y to get everything on one side. So those are our major constraints. It's also good to note that our x has to be greater than or equal to 0, and a y has to be greater than or equal to 0. We can always have nobody come, but we can't have negative kids just to get more parents, or negative parents just to make seats for kids. So that's our full system of constraints. Now again, you certainly know how to, or I hope know how to take your constraints, graph your constraints, find your feasible region, find your points on your feasible region, plug them into your objective function to find your maximum revenue. But to be clear, this question says set up an objective function in a system of constraints that will find the maximum money that can be raised in terms of the number of children and parents in attendance. Set up the objective function and set up the system of constraints. We have set up the objective function. We have set up the system of constraints. We're done. Do not spend an extra 10 minutes solving a question you weren't asked to solve. Read very carefully. If you're told to set up, notice I try to put things like, this is all bold and capital, this is underlined. Make sure you, even if they're not bold or underlined, that you read carefully so you make sure exactly what you're asked to do. So you don't spend a lot of time doing something you're not asked for, or answer a question that is slightly different than what you were actually asked. So be careful about that. You're asked to set up the system, set up the system. If you're asked to solve a system, solve the system. Okay, 16 minutes in. Let me try to do the other ones on another video. I'll see you soon.